Hi, Marty Dwyer with Boat Anchor Audio. For all you audiophiles and experimenters out there, we have something you might find of interest. You've all heard of the UAF-42. It's a universal audio filter made by Texas Instrument. Very popular, very expensive. What we have here is something that's not a clone of a UAF-42, but it's a development board that's based on the TL074 op amp. Now, this old boy's been around the track a long time. It still has respectable numbers, pretty good slew rate, and relatively low total harmonic distortion. Certainly good enough for the purposes here. Anyway, what we've done is come up with a development board based on the TL074. Now, what is a development board? What we have here is a printed circuit board with a TL074 on it. It's configured to be a state variable filter. However, we've brought out the important components to terminal blocks, such as the potentiometers, the dual pot that controls your frequency. That's brought out the terminal block. Your capacitors that control frequencies, they are also brought out to terminal blocks. The input is brought out to terminal block, of course, and the output gives you low pass, high pass, and band pass output. You also have access to varying the Q as necessary. If you look along the bottom there, you'll see 4 terminal strips. Now, the one on the extreme right is merely a grounding block. It's for grounds for whatever reason. The other 3 bring out the unused op amp on the 74. Now, as you know, a TL074 has 4 op amps on it. A state variable, at least this one, is only using 3 of the op amps. The 4th op amp is unused. Now, the terminal blocks are set up so you could use the op amp as an amplifier, as a buffer with additional components. It could probably be used as a notch filter. All right, here's another picture of the finished product. You'll notice that the op amp terminals are jumpered. You have to jumper this thing properly, terminate this properly, or else it may take off, go out to la-la land, and cause some instabilities. Anyway, that's our printed circuit board. Now take a look at the schematic here, and as you'll see, it is really nothing more than your standard, ordinary, run-of-the-mill state variable filters. The terminal blocks are clearly shown there. Inputs, outputs, access to your unused op amp. So now we also have some test results that we've done here. This is done using a network analyzer, namely the network analyzer function of the analog devices too. The first one shows the output as configured as a high-pass filter. Now, as you know, a high-pass filter, a 2-pole high-pass filter or 2-pole filter, will roll off at 40 dB per decade, and you can see that on the test result. The second one is a bandpass filter. It's configured as a bandpass filter. The Q on this can be made fairly high, but if you make it too high, it can be unstable, so you have to watch your step here. The third one shows the output as a low-pass filter. Again, it's a 2-pole filter, rolls off 40 dB per decade. Anyway, that's it in a nutshell. There's a picture of the schematic again. And we've been fooling around with this in a lab for some time, and we're pretty pleased with the results. The cost to build something like this is minimal, the main cost being the printed circuit board. If you buy them in quantities, they're not that expensive. Anyway, we're waiting for the boards for our next project, which is going to be a notch filter. We've done simulations on our notch filter that looks very promising. Anyway, if you have any comments, let us know, and we'll get back to you as soon as we can. In the meantime, keep those electrons flowing. Talk to you later.